Today I am discussing very interesting topics, that is Kepler's law. Law play vital role in planetary motion. Today I am discussing a very interesting topic, that is Kepler's law. This is very vital role in case of planetary motion. Kepler had given 3 laws. This is very important for different purpose. First, we come to the first law, that is a planet moves around the sun in an elliptical orbit with the sun situated at one of its foci. This is the law of elliptical orbit. This is the first law. A planet moves around the sun in such a way that its aerial velocity is constant. That is, the line joining the planet, this is the planet, position of planet and sun, this line with the sun sweeps equal areas in equal time. So this area, that is aerial velocity, is constant. When the planet moves this position to this position, then this aerial velocity is constant. We have to prove. This is called the law of aerial velocities. So we know this is a ellipse. So this is ellipse. So this is the semi major axis and this is semi minor axis. And come to the third law. Third law, that is a planet moves around the sun in such a way that the square of its period is directly proportional to the cube of semi-major axis of the elliptical orbit. So this is the time period t, and this is a. So we can write that is t proportional, that is this is a, that is cube, that is a cube. So time, that is square t square. So t square proportional, we can write that is t square proportional a cube. We have to prove this. And here we have to prove that is dA dt constant. We have to prove this. Kepler's second law proof. Second law, this is x, y, z. Let at any instant, that is planet is situated A and it goes to, that is B. So let the planet moves from A to B in time small, that is small t. So we can write the position vector, so changes r to this, we can write. So in this, that is this minus this, so that is small fraction, that is small portion, that is delta r, we can write. So area, this area, that is half into base into height, we can write half into base into height. So putting this value, this is delta r, we can write delta r. We know v equal to r by t. So using this formula we write this. Then p is the linear momentum, so p equal to mv. So putting the value of v from this equation in this equation, then we can get r cross p. So r cross p means that is angular momentum. So hence we can write dividing del t on both sides, we get del A by del T equal to L by 2m. So this is constant. For an isolated system, L is constant. So L, that is angular momentum, constant. So we can write that is this part, that is del A by del T, constant. So we can write here that is dA dt. This is aerial velocity. So aerial velocity constant. So this is the Kepler's, that is second law. So this is the Kepler's second law, very important. Now we come to the proof of Kepler's third law. So here we draw an elliptical orbit, Sun. Here the S is Sun. The planet moves from P to P1, makes an angle that is d theta. Let a planet moves around the Sun S in elliptical orbit. This is elliptical orbit. So this is an elliptical orbit. The planet moves in an elliptical orbit at any instant, that is position of planet is P. After some time, that is position, that is P1, makes an angle d theta. So this Sun is at foci at this ellipse. So with the help of this diagram, we have to prove that is Kepler's third law. So planet moves around the Sun, in an elliptical orbit. The Sun is at the foci of this orbit. So Sun is here. So length of the semi-major axis 2a. This is the 2a, length of the semi-major axis 2a. So length of the semi-minor axis, that is 2b. We can write. So we can write. So area of the ellipse, that is pi AB. Before we have known that is dA dt equal to L by 2m. So I have write down this equation. So we can write that is area by aerial velocity. So we can write that is time period, that is area of the orbit by aerial velocity. So area of the orbit this. So we know that is time period, area of the orbit by aerial velocity. Putting the value of area of the orbit and aerial velocity, so we get this is the t equal to 2m pi. So putting the value t equal to 2m pi AB by L. So from mathematics we can get that is L equal to b square by A. So we write that is b square equal to L. So b equal to root L. Putting the value of that is b in this equation, we get this is the. So we have to transform all the things in respect of A. So squaring, this is the equation. Squaring on the both side, we get this is the portion. So t square proportion A cube. This is the Kepler's third law. So this is very important for the different exam. I think this class is very much helpful. Please watch all the videos and subscribe and share all your friends. Thank you all my dear students. Please comment if you have any comments. Thank you.